In example 2, we're going to factor a couple trinomials, and we're going to note that these trinomials look very similar, but they have different signs on the 10 and the 24. So in A, for instance, our A value is 1, B is negative 10, and C is positive 24. So A times C is 1 times 24, which is 24. Let's make a list of our pair of factors. 1 and 24 is a possible pair. But if they're going to add up to negative 10, I'm probably going to need two negative factors. So there's negative 1 and negative 24, negative 2 and negative 12, negative 3 and negative 8, negative 4 and negative 6. And that's pretty much all of our pairs of negative factors. Let's list their sums: negative 25, negative 14, negative 11, and negative 10. Bingo, that's the one that we want to use. So let's split the middle term. X squared minus 4x minus 6x plus 24. By the way, it doesn't matter what order those two terms go in. Negative 6x can go first. Now let's split the middle term. X times x minus 4, and factor by grouping, minus 6 times x minus 4. So this factors into x minus 4 times x minus 6. And now let's work the second example with our signs switched. So this time A is 1, B is positive 10, and C is negative 24. So A times C is 1 times negative 24, which is negative 24. Our pairs of factors need to be one negative and one positive. Now the positive value is going to need to be of larger size than the negative value because these have to add up to positive 10. So let's try negative 1 and 24 is one pair, negative 2 and positive 12, and I think we found our pair because the sum of those two is 10, while the sum of the first ones is 23. So that's the pair that we want to use. And let's factor x squared minus 2x plus 12x minus 24. And that's x times x minus 2 plus 12 times x minus 2 when we factor by grouping, giving us final factors of x minus 2 times x plus 12. And what I really want you to take from this is looking at both of our examples here. Notice how differently each factored when we just change the signs. All right, in example 3, we are going to find all possible values of b for which 3x squared plus bx minus 6 can be factored. Note we're just missing the value of b, right? We know what a and c are, so we can approach this with the AC method. A times c is 3 times negative 6, which is negative 18. Let's make a list of all possible pairs of factors here. And our pairs of factors would be 1 and negative 18, 2 and negative 9, 3 and negative 6, 6 and negative 3, and would that be 9 and negative 2, and finally positive 18 and negative 1. It's helpful if you can make a really organized list here. And then we're going to find their sum. And remember, their sum is what b is. So their sum is actually all the possible values of b for which this can be factored. 1 plus negative 18 is negative 17. 2 plus negative 9 is negative 7. 3 plus negative 6 is negative 3. 6 plus negative 3 is positive 3. 9 plus negative 2 is 7. 18 plus negative 1 is positive 17. So the answer is all of these values will give you a polynomial where if b is that value, then that polynomial could be factored. If b is anything other than those 6 values, this polynomial will not be able to be factored. All right, now let's take a look at something called a perfect square trinomial. You'll remember this one from a previous example. And we wrote that in factored form as k minus 5 squared. That makes it what we call a perfect square trinomial. And perfect square trinomials always come in this form. A plus b squared is equal to, and if we FOIL a plus b times a plus b, we'll get a squared plus 2 times a times b plus b squared. I want you to notice that the first and last terms are perfect squares, and that the middle term is comprised of 2 times the value of a times the value of b. And a variation on this, a minus b squared, is a squared minus 2ab plus b squared. Again, first and last terms are perfect squares and are positive, and the middle term is the opposite of 2 times a times b. So what we're going to do in example 4 is we're going to look at some polynomials and determine if they are in fact perfect squares. And when I look at my first term here, 3w squared, this is not a perfect square. Had it been 9w squared, then it might have been a perfect square. In that case, this trinomial is not a perfect square trinomial. So we're not going to factor it. In B, notice that 9x squared is, in fact, a perfect square. It is 3x, the quantity squared. That's our a squared, right? So a is 3x. And the last term is a positive perfect square. It is, in fact, 5 squared. So that's our b squared. That middle term is 2 times a times b, which is 2 times 3x times 5, which is 6x times 5, or 30x. Or it can be negative 2ab, which this one, in fact, is. And so this factors into 3x minus 5, the quantity squared. All right, let's take a look at C. Our first term is a perfect square. It is the square of u. The second term is not a perfect square because it's not a positive number. A perfect square by definition has to be positive because a negative times a negative is a positive, and a positive times a positive is also a positive. So this means that this trinomial here is not a perfect square. In D, our first term is a perfect square. It is the square of 10y. Our last term is a perfect square. It is the square of 7. And if this is a perfect square, our middle term will be either positive or negative, and in this case negative, 2 times a times b, which would be negative 2 times 10y times 7, and that will in fact give us negative 140y, which is our middle term. So this must factor into 10y minus 7, the quantity squared. All right, let's check out E. The first term is a perfect square. It's the square of 2a. The last term is also a perfect square, the square of 3b. And if this is a perfect square trinomial, our middle term will be negative 2 times a times b, fit that pattern. So negative 2 times 2a times 3b, which would give us negative 12ab. So this is in fact a perfect square. It is 2a minus 3b, the quantity squared. And last f, our first term is a perfect square. It's the square of 4s. The last term is also a perfect square. It is the square of 5y. If this is indeed a perfect square trinomial, then the middle term is 2 times a times b, so 2 times 4s times 5y, which is 8 times 5 is 40sy, and so our middle term is not the right size, and so this is not a perfect square. In order to be a perfect square, it would have to have a middle term of positive or negative 40sy. All right. A polynomial may factor more than once. When that's applicable, we're always going to start by factoring the greatest common factor from the polynomial first, and then checking to see if the remaining factor can indeed factor again. So in example 5a, we're going to start by factoring the greatest common factor. 3 is the greatest common factor that divides into all three of those terms. Factoring out the 3n squared minus 5n plus 4 is left, and the remaining trinomial can be factored again. The trinomial inside the parentheses has an a of 1 and a c of 4. So a times c is 1 times 4, which is 4, and pairs of factors of 4 that add up to negative 5. The pair that we're looking for is negative 1 and negative 4, because negative 1 times negative 4 is positive 4 and adds to negative 5. So splitting the middle term, n squared minus 1n minus 4n plus 4, and that's n times n minus 1 minus 4 times n minus 1, or n minus 1 times n minus 4 in factored form. Don't forget, however, to bring down that GCF to the last step, because 3 is one of the three factors of this polynomial. In B, we can factor the greatest common factor first, which is negative 4v. Since the lead term has a negative coefficient, we're going to factor out the negative of the GCF. Negative 4v times 3v squared plus, and in fact, the greatest common factor is not 4v, is it? It is 2v. So factor out a negative 2v, and that will leave us with positive 6v squared plus 7v plus 2. And the remaining trinomial has an a of 6, b of 7, and c of 2. So a times c is 6 times 2, or 12. Pairs of factors that add up to 7 are 3 and 4. So split the middle term, 6v squared plus 3v plus 4v plus 2. And now factor by grouping, 3v times v plus, or rather 2v plus 1 plus 2 times 2v plus 1 gives us factors of 2v plus 1 times 3v plus 2. But don't forget about that greatest common factor. Let's bring that down to go with your final answer. All right. In example 6, we are finding the solution set for each equation. So now we are solving an equation. We're going to use factoring as a tool to solve each equation. This one's already equal to 0, so all we need to do is factor, and we're going to start with the GCF, and k divides evenly into all of those terms. So we have k squared minus 7k plus 12 when we factor out the k, and we can factor once again. And that trinomial on the inside has an a times a c of 1 times 12, which is 12. Factors that add up to negative 7 are negative 3 and negative 4. K squared minus 3k minus 4k plus 12. And that's k times k minus 3 minus 4 times k minus 3. And so our factors are k minus 3 times k minus 4. And don't forget to bring that greatest common factor down. So k times k minus 3 times k minus 4 is equal to 0. And when three factors multiply to give a result of 0, one of the three factors must be equal to 0. And if we solve all those individual equations, we get three solutions, 0, 3, and 4. We actually could have known that we might get three solutions by looking at the original equation, which had the highest degree of 3. That is, k is raised to the third power. Let's try one more. 6m squared minus m minus 2. Since the highest power of m is 2, I'm expecting two solutions. So this one, we don't need to factor out GCF first. We're just going to factor the trinomial. So A is 6 and C is -2. That gives us a AC of -12. And we need a pair of factors that add up to -1, which is the value of B. Those will be -4 and 3. So factor by grouping, 6m squared minus 4m plus 3m minus 2 equals 0. And we can factor the first group. 2m is a common factor. That leaves us with 3m minus 2. And in the second group, 1 is the greatest common factor. That also leaves us with 3m minus 2. So our factors are 3m minus 2 times 2m plus 1, which equals 0. So either the first factor is 0 or the second factor is equal to 0. And if we solve each one of those, first equation, add 2 and divide by 3 for a solution of 2/3. Second, subtract 1 and divide by 2 for a solution of -1/2. And there's our solution set. Moving to C, try this one on your own, and let's pause the video while you do this. This equation should give two solutions of +1/8 and +2. Let's move on to D and try this one on your own and pause the video while you try this. This equation should have 3 solutions because there are 3 factors. Notice that we had a u cubed as the highest exponent on the variable u in the original equation, so we were expecting 3 solutions. It also doesn't matter what order the solutions go in, so you can list -5 first, or you can list it last. It doesn't make any difference. Alright, in example 7, we're going to do one more step, and these examples we have an equation to solve, but we don't have 0 on one side. So in A, we're going to subtract 9y from both sides. And now we have a trinomial equal to 0, so we can now factor. Make sure to put the terms in descending powers of y when you do subtract and move the terms to one side. So our A value is 2 and our C is -5. 2 times -5 is -10. The factors that add up to -9 are +1 and -10. 2y squared plus 1y minus 10y minus 5. And we can factor a y from the first group. That'll leave us with 2y plus 1 minus 5 from the second group. That also leaves us with 2y plus 1. So our factors are 2y plus 1 times y minus 5 equal to 0. And either 2y plus 1 will be equal to 0 or y minus 5 will equal 0. If we set 2y plus 1 equal to 0, we're going to get a solution of -1/2 when we subtract 1 and divide by 2. And when y minus 5 is equal to 0, by adding 5 to both sides, we get a solution of 5. Now let's try B. Before we can move terms to one side of the equation, we need to multiply before we can subtract. Multiplying, we're going to use the FOIL method. The product of the first is x squared, the outers 3x, the inners 4x, and the lasts 12. And now I'm going to move the 15x to the left side of the equation. 3x and 4x are 7x. When we subtract 15x from both sides, we'll get minus 8x plus 12 equals 0 on the right side. And now our A times C is 1 times 12, which is 12. Factors of +12 that add up to -8 are -2 and -6. So x squared minus 2x minus 6x plus 12 is equal to 0. Factor by grouping, x times x minus 2 bring down the minus sign in between the two groups and factor the 6. Then we have x minus 2 left over. So our two factors are x minus 2 and x minus 6. And so if x minus 2 equals 0 or x minus 6 is equal to 0, the two solutions are 2 and 6. All right, it's your turn to try. Try C on your own, and let's pause the video while you do this. This equation should have given you two solutions, -1 and +1/3. There's one last example. Let's try this one while you pause the video. This last example should have yielded two solutions, -1 and +1/2. That's it for the lesson.